Hi, everybody. My name is Floyd Christofferson, and I'm joined with my partner in crime, Brian Bashaw, Field CTO from Hammerspace. And we're coming to you today with the next in our series, LinkedIn Live series. This one, and it actually came about after the last one we did a couple of weeks ago, which was about automated data placement and workflow management of data across silos. And today, we're going to talk about, again, automating non-disruptive data migration. And the reason is, the last conversation, Brian, as you remember, we went a lot into how workflows can be automated to bridge data across silos and so forth. And I think you got some contact, some of your friends and people, acquaintances, they said, hey, we want to know more. We have this problem of data migration all the time, right?
Yep, had a couple of private messages, some emails, even had somebody reached in over LinkedIn and connect with a similar question, a similar challenge statement.
So let's set the stage a little bit. I mean, what we're really talking about here is unstructured data, right? So unstructured data, loose files that might be, in a genomic sequence environment, or more typically, biosciences of some sort, or oil and gas, or media and entertainment, or weather data. We're talking about data that might be a few hundred terabytes to multiple petabytes. So, talk a little bit, Brian, about why data migration is. Before you do that, as a reminder to everybody, if you do have questions, please put them in the chat and we'll see them and we'll address them as we go along. But talk a little bit about why data migration is a challenge. I mean, I know from my own, on the shelf behind me, I've got some old hard drives that have, I don't know how many thousands of images and MP3s and pictures, family pictures and so forth. And I've got one old drive over there, another old drive over there. This computer over here's got a bunch of old images. And I know just on a level of an individual, managing those copies from place to place can become a challenge. So talk a little bit about what the reality is in an IT environment, for managing copies of data across different silos.
Yeah, Floyd, your story reminds me of an opportunity I had to work with a consulting firm, we'll call them. And the gentleman would talk about this exact problem, and it's not limited to the shelf behind you. It's, as a matter of fact, it extended very much into a very real genomics-based research organization. And the gentleman would start out his presentation all about this problem, by the way, data management, metadata, all the fun stuff that we've been talking about. But he would start that conversation out with a picture. And that picture would be of a normal lab that we've all been into in chemistry class before. Nothing new to see here, except that over in the corner is the chemical bath, the wet, the little shower and the eye wash and all that. And right on the little sink, the drain pan, was a stack of USB hard disk drives with Post-it notes with project names written on them. And that, in that world, was their challenge in terms of organizing and cataloging data itself associated with their projects. And all of that fed into, you get into these places where people just don't know, in a lot of cases, how to deal with moving data from one place to another and doing so reliably or in a way that they can trust, that they can actually get rid of those hard drives. I mean, you're still holding on to those drives in your environment for one reason or another. And I would venture to guess it's because maybe one day I need to get back to the original just in case. And that leads into some of those challenges. You start talking about the challenges in a normal IT data migration workflow, and you start thinking about things like, first off, just standing up a parallel infrastructure, having to think about running now 2 storage infrastructures that match that size of the original one. So you start talking about your, go ahead.
So for example, I mean, I may start with an individual silo, right? An individual storage type that is just fine. But then, over time, I need to add a second one, right? So And so, from what started as an individual access point to the data, I now have a second one that needs to be managed, right? And so what happens?
Well, where do you start with what happens? So you stand up that second one. You've now got to elevate that view of all of the content that was on the first one to be, well, as much of it as you want to be visible on the second one. You may have to pick and choose the capabilities of those systems and decide which one makes sense to place data on or the other. But then you've also now got to figure out, okay, well, as I'm going to move the data from one to another, how do I deal with verifying that what moved was in fact what was supposed to move, that it's actually still good? We throw around words in the data world like durability that a lot of people don't think about unless you're buying a pickup truck. But durability in the world of data simply means, can I sustain various failures within the environment? And those failures might just be that I flipped a bit in transition from one storage system to another and you wouldn't know it behind the scenes. But I mean, you kind of keep going with that and think about having to keep these systems up in some amount of time frame together. Then I've also got to map users to the new resources. I've got to take the downtime associated with that. It's a gigantic headache. It takes time.
So let's walk through that a little bit. And I don't want to focus too much time on just the problem space, but also get a little bit later to the ways that we can fix this. And if you're just joining us, this is a LinkedIn Live event from Hammerspace. I'm here with Brian Bashan. We're talking about unifying data silos and really focus in specifically on data migration and how to automate this. Because I think what you'll agree, Brian, is that, actually just walk us through. I mean, we've got two silos on the screen now, but, the reality is that as environments grow, you may have multiple, right? Different, and so why would you migrate, and what is the process in a typical IT environment for actually doing this migration?
Yeah, so let's start with why. I think it's an important place to start. Why? You made a decision to implement whatever, whatever storage array you did, and it met the requirements. Maybe if you were lucky, if you planned right, it met the requirements that you had in that initial moment in time. But those requirements will change over time. Data doesn't necessarily need to live on the highest elevated tier in your environment forever. It might need that for as long as that project is active and being worked on. But over time, that should be able to be moved easily and have data be repurposed. And there are certain tools associated with moving data down the stack like that. We've been using HSM tools and things like that for a long, long time. But I always get stuck at that point if you're thinking about data moving down from from a higher performance silo to maybe a lower end silo. But data can also move up, right? And you think about just in your own machine, how data flows in your environment, whether it's living on, a hard drive escalated to a RAM cache somewhere, escalated to L2 cache sitting next to your CPU. Those are all things that just sort of happen in your environment. Wouldn't it be really cool if you could bring that into your own data flow now at this point? Data migration across all those different capability tiers just sort of becomes something that happens rather than something you have to plan for.
But isn't it true? I mean, I think you made an important point. I mean, we were joking around a little bit in the beginning about, the stack of USB drives and so forth. But I mean, the reality is that any sophisticated IT organization, there may be shadow IT we can talk about, but any sophisticated IT organization, they've made a very careful plan. They've bought their primary tier storage. They've got their data, their access. But isn't there a problem that if you now either that data silo fills up or it ages out, or you need to a different performance level or different cost profile, isn't there a problem of having to run things in parallel when you do these migrations? And what does that do to the complexity and cost?
Sure. I mean, start at the beginning. Do you have physical place to put the new thing that you're going to move into? That can be a challenge. The power and cooling associated with that, and running those things in parallel for whatever that time's going to be. So right out of the gate, you got to think about that. You've got to start that planning from the moment you deploy the first one. I once upon a time was supporting a large super major oil and gas company when I worked for another storage firm, and they would establish a 5-year storage strategy document, and part of that document was how are we going to transition from the old strategy to the new one. So they were planning that and living that life 5 years at a time. And in that world, they kind of knew, well, this is when our maintenance agreement expires on this new storage silo that I'm putting in place. We need to define our 5-year strategy every 3 years or so that we can get the new thing put in, have that time to migrate data over to it and start benefiting from the value that they're paying for day one. So I mean, it starts with that, Floyd. It's how do you even just get started running these parallel infrastructures and do so in a time frame that allows you to get out of the old one onto the new one. And then comes all the other fun stuff in terms of orchestrating users to the new thing, mapping those resources over, et cetera.
So, I mean, doesn't it often come down to, this frenetic over the weekend, cut over from old to new, maybe, and now you've maybe moved the data or copied the data across. And so now but then you've got forked copies where, you get some of it on the new storage and some of it on the old. But, if we go back to that image, where you've got all of these different access points to the data, how, it becomes a frenetic thing, right?
Yeah. And I mean, even there, it starts with, okay, cool. We think we've migrated everything over. We think we're at a checkpoint. Let's run one more verification against that and make sure that we're good to go. Maybe sync over any last minute changes. But then, I jokingly call it the dark side of the moon moment. There comes a time when you're going to say, all right, let's cut everybody over to the new thing, restart all those services and hope for the best, and that's never a fun moment. You definitely want to try and do that, after hours. You want to do it when people aren't using the system. But these days, when are people not? So, yeah.
So, in the consumer world, this problem has been solved, right? I mean, when I get a new phone, I know that, it goes through its migration, but I'm not sitting around copying and, files from one device to another. I mean, not that long ago, I had to do that. When I got a new computer, I would copy from one to another. But I mean, in the consumer world, this is pretty well, it becomes pretty well, an easy thing to do, right? But how does this transfer then? We've got this problem in the world. I mean, isn't there a possibility? Shouldn't this be possible, even if you're dealing with petabytes of data and hundreds of millions, if not billions of files?
Yeah, and I think, in that world, at least in my experience, I'm with you. I haven't had to worry about migrating data manually between laptop or phone or whatever, tablet devices. I mean, I'm more or less set up at this point. I can, go full on, Tom Brady on a laptop and zing it across a football field, and I've still got all my content. It's not a big problem. But now you start escalating that into that enterprise space, and now you've got a different challenge. It's not the same access protocols all the time. It's not the same users. It's not the same locations. And so you start having all of these different options that come into play that you've got to plan for. And those simplistic migrations of new phone comes out, throw away old one, and I'm good to go aren't quite so simple anymore unless you can actually take ownership of that metadata and that presentation of that data to those users.
So, typically there's environments such as, or there's solutions, called data management solutions, right? And often these attempt to help with this, or there's point solutions to manage, migration across, but it doesn't solve the fundamental problem of bridging the silos. So why wouldn't somebody just, buy everything? I mean, I guess it's a leading question because I have an answer for as well. But, wouldn't buying everything from all of your storage from a single vendor solve that problem?
You'd like to think so, but not in all cases. We're working I'm actually working on a project with a customer right now that they have everything in one vendor, but they've also adopted a cloud strategy. And so there is a leg of their environment that lives in a public cloud. However, the coupling within that vendor that says, here's where that data now lives, or here's how we're going to satisfy this multi-site environment, that coupling always assumes some single authority in their environment. And if I want to move the location of that authority from one system to another, doing that requires a migration out of the cloud entity and back into the new thing. So even doing that, if you think about it from a round trip, how to bits flow, that means moving from on premises to the cloud. Now let's rehydrate that back to the cloud to the on-prem instance so we can migrate into the new thing back into the cloud. And don't even ask what happens when I decide I want to run my primary workflow from that in the cloud as well. Whole nother challenge for them.
Yeah, I was reading a study from the Linux Foundation. They, like everybody, they do their year-end wrap-up of trends in the storage industry and so forth. But one of the things that caught out to me is, you'd think that if you buy all of your storage, just from the same vendor, it would be easy. But of course, not everybody wants to stick with one storage or doesn't necessarily want to be locked into one vendor. But nevertheless, I mean, does that? But the statistic that caught out to me was only 12% of large organizations, and we're talking hundreds of terabytes to petabytes level organizations. Only 12% want to keep all of their data in one vendor silo or one vendor, I call it putting all of your data eggs in one vendor basket, right?
Sure.
I mean, the reality is we know, there's new storage choices. I mean, there's vendors that come up with new platforms, new economics. There's clouds. There's multiple clouds, and so there needs to be this way of being able to automate this, right?
Yeah, of course. Well, and we all do in the storage world, we all do new and different things, in some ways better or worse than other people in the environment. And so it makes sense to have a full heterogeneous environment. Having everything on that one vendor, I don't know. My wife and I maintain 2 separate cell phone providers, just in case one of them goes bad while we're out on vacation or can't have signal on one, I might have the other. So yeah, it's probably a good practice.
So we hear this term data gravity, right? And data gravity, I mean, I think to research organizations that I've visited over my career, where there's a central IT organization and they have all of their main storage, but then a department or a project will get a grant, and that grant enables them to buy stuff, and maybe they don't want to put everything on the central IT storage, and so they buy a Drobo or a Synology, and they throw it under their desk and off they go. This is called shadow IT. So you now have copies. And secondly, then you have this problem of data gravity, which is, well, define what data gravity is for everyone.
Yeah, I think there's even this joke now that we were just talking about just this morning again about, or maybe it was yesterday, but joking about how we're used to just calling this place that we go to, that our infrastructure exists in, we call it the data center. And really at this point, data being able to go pretty much anywhere, it's almost sort of a silly thing to say anymore to call it the data center. It's not necessarily the center of your data. And that ties right back into that data gravity conversation. You used the example a moment ago about a research organization that gets a grant. So they're going to have requirements for not only their data and that data and the protection durability of that data, but they're also going to have requirements for performance capabilities of that data. And that is now going to drive this idea that data has to move to that application because of its own requirements. Having data live in a singular place that has this sort of universal approach to accessing it, that's sort of what data gravity is all about, where services move to the data itself. And this idea, though, in this world where we now have services that are executed all over the place in the cloud, on-prem, remote data centers, desktop, home offices, all of those things coming together, starts to turn into this place where data doesn't pull services in anymore. Services live where they live, and the relevant data has to be pulled towards them. So you've sort of almost flipped the magnet away, and now they're pushing each other away from each other in some cases.
So what we're talking about here is data management strategies or data migration. These are often events, right? They're events that have to be scheduled with the IT team, scheduled with the users, and so forth. But shouldn't this always be a process? Like you mentioned in the beginning, a large IT organization is thinking 5 years out. So that, shouldn't this always just be a process, right? So that it's non-disruptive?
It should be. You'd like to think it is. Excuse me, but it doesn't always work out that way, right? I mean, a lot of bigger organizations have somebody that's dedicated purpose in that organization is a data strategy role, a data strategy officer we've heard of in the past. But smaller organizations, especially some of these research institutions where you have your geoscientist is also your system admin, probably isn't a very good data strategy person to be relying on. So a lot of times these decisions come down to the last minute and best effort.
Sure. And we had a question related. I mean, what we're really talking about here primarily is unstructured data, but there is structured data. There's, containerized workflows, and we won't go too deep into that. But I mean, ultimately, it's the same problem, right? Where you have data locality, you need data access. You've got different resources, whether it's on-prem, in the cloud, whether you need to burst to compute infrastructures in the cloud, whether your database system is managing the location of those databases, or whether it's a user or an application. Isn't it fundamentally the same problem, right?
Yeah, of course. Challenges I think you run into with unstructured data is also a lack of external management. Structured data generally comes with some sort of coordinated effort of quiescing access to data and making that transition for you, and it tends to be very application centric, very application driven. In that unstructured data world, it's almost still that wild west. I mean, it's what we're 24 years since the first time I heard of an Auspex, way back in the day, and we're still struggling with those same challenges.
So let's talk about the way we solve this problem. So at Hammerspace, if you can go to the next graphic, please. At Hammerspace, yeah, thank you. So at Hammerspace, I mean, one of the issues that we talked about earlier is that the metadata, the file metadata, which is what people interact with. I mean, the bits are down on the platters somewhere, right? If I'm looking into my primary storage array, the bits are on the platter, and I interact with those bits via the file system. If part of my file is on one platter or on another platter, I don't know and I don't care. With Hammerspace, what we've done is reverse that. Instead of the file system being locked at the infrastructure layer, we've actually elevated that file system out above the infrastructure layer. So now as a user, I'm looking at my files. Not unlike with my phone, I'm just looking at my files, and whether they're in the cloud, whether they're on my local hard drive, whether they're all of those places, I'm looking at the same file system metadata. And that means I can choose which location the files move to non-disruptively in the background, right?
Yeah, I mean, think about the phone analogy that you were using a moment ago. And now think about, if you dive in far enough into the menus of your application, pick your photos application on your phone. Maybe it's your music library, whatever it is. Oftentimes, if you dive far enough into the weeds, you'll find the little slider or the option that says how much of that should actually still live on my phone versus live in iCloud or Google Drive or whatever your choice is. But that point of view, to your point, Floyd, that point of view to you, the user, is always consistent. There may be a slight delay as you go fetch a new video down from the cloud while it starts buffering to stream to you, but you didn't have to know to go look in that cloud provider to go get that content, right?
Mm-hmm.
So now if you play that forward a little bit, that's that application knowing where that data lives. But at the same time, now if I bring another device up, it's not unheard of to take a photo on my iPhone and then suddenly turn around and move over to my laptop and start editing on that photo. I now have that same metadata visibility across clients, all within a specific ecosystem, all within a specific application set. But now I'm still referencing that same point of view of data and being able to make those edits consistent across multiple environments.
Which means also you can choose whichever storage vendor you want in the background. So get the benefit of your storage vendor of choice without the problems associated with copy-based data management, right?
Exactly. Well, and then there's the other thing too. We spend an awful lot of time when we talk about this kind of stuff. We talk about marrying up existing data with this new environment. But I always like to remind that there's also the reverse challenge. You know, you don't ever get a chance to go buy exactly the right amount of storage that you think you're going to need. Mm-hmm. Right? You can't get that down to the kilobyte or byte level to say this is exactly what I need. And there's always some capacity still sitting somewhere trapped behind that local file system that you can't get access to either. And so not only are you bringing the presentation of your data and the capabilities of those storage systems up into that metadata tier, or into that metadata view rather, but you're also bringing in all the free capacity that's aggregated across all of those different silos behind the scenes into that metadata tier as well.
Well, and that also brings up another point. When you're using data management by copy, right? So I've got my primary copy someplace. In order to share it with, another location, maybe I have to robocopy or rsync whole data volumes to that other location, or move that, or if I'm doing a burst to cloud workflow, I'm having to move whole volumes. But if the file system is consistent across, then it's only the data that I'm actually using that needs to not copy, but actually the instantiation of that data now can move. Doesn't that save me on stranded capacity? Doesn't that save me on just how the proliferation of copies?
Well, and that's one of the most important yet subtle traits of all of this conversation is if you're living in that traditional migration world, you are making copies. That's the purpose of the migration, copy from one place to another. But what if instead, let's go back to that idea of how the data might move just within an individual unit of storage, a hard disk drive or a flash device of sorts. Data might move from one cell to another, from one platter to another. But that's all masked from you because the metadata just says, I know that this is the pointer to where data lives on a physical device. Well, if I could make that now consistent across multiple devices, there's where you get into what a storage array does, a traditional storage array does. But what if you could elevate that a little bit further and say, not only do I know about all the different media, not only do I know about all the different storage systems in the environment, but what if I could just say, I don't really care about any of those things. My metadata pointers all just say I have an instance of a file on a storage system that lives in site A, and I might want to create another instance of that somewhere else, but I don't necessarily have to copy the entirety of that data set around. I can do that now non-disruptively and kind of passively behind the scenes. It's just sort of an event that happens.
So rather than migration, what we're really talking about here is data orchestration, right? So migration is a copy-based management strategy to deal with bridging silos, whereas orchestration is an automated process, right? Driven by the metadata, which could be, standard tiering type of metadata, or it could be other types of metadata that enable this to happen as an orchestration behind the scenes, right?
Well, and we use this word orchestration, and it's a word that is by and large reserved for DevOps folks or container-oriented workflows and that kind of thing. But thinking about it instead in terms of that data placement, if we're all comfortable with the idea that data in the data center no longer has that gravity, that pull to it, well then I can start applying similar sort of thought processes to that data movement, that data placement, and refer to it as orchestration. And in that world, what we're talking about now is being able to say, just like you do in a container world, where you identify not only the service that's going to run, but the resources required to do it, and you can dynamically scale those out or shrink them back in response to use. Wouldn't it be cool if you could do that with data as well? Being able to say, this is what the current needs are of a specific data set based on its real-time view of that access, and say, you know what, let's go ahead and elevate that to some other tier within that environment, or elevate it to, or sorry, not elevate, but place it in a remote location. If suddenly activity starts up at a remote site, unplanned for, it just sort of happens. How cool would it be if the data could just manifest itself in that other location and give the capabilities required to satisfy the user?
So you may buy an array, a storage system from a vendor that has both SSDs and spinning disks, within the same hybrid system. And
Sure.
it will promote or demote the data placement within those different storage parts. But what we're really talking about now is the automation of this we get to larger scales, also across time. So that even if you were to buy the next platform from that same vendor, or maybe you do want to shift some stuff to cloud, or you do have a remote office. Now, with the metadata, because the file system is no longer locked in at the infrastructure layer, you can still take advantage of that storage vendor's, unique capabilities within the hardware, right, within the infrastructure. But the file system is above. So now, as you see in the top left of that graphic, all of that data movement, that orchestration now moves below the file system. So the applications and the users, they just see their data, right? They just see their files. Where if you want to move data around, I think of it like a fabric, and it's kind of like the center of gravity, now becomes based on use. Not as a negative, but in fact, you've defied gravity because the data can flow where it needs to do in the background, and then so now data gravity ceases to exist. You've now moved above that. So the data can flow where it needs to flow. You can manage instantiations of that. You can protect it. You can move it to other sites, and because everybody's looking at the same files, right?
Yeah, and it sort of simplifies that. All of the things that we talked about early on around migration, there's a whole other separate set of things that come on to play with that. And thinking about things like making sure that my permissions are set up appropriately, making sure that people still have access to even see those resources on that fabric. But if all of those things can be managed at that metadata layer, and we just treat the storage entities that are on the network as tenants of that metadata layer, well, then I can set my permissions up one time. That becomes a thing that lives with that metadata element. The blocks might move from one storage tier or storage system to another. They might move from one location to another, but all of the metadata properties associated with governing access, protection, as you were talking about a moment ago, performance needs, all of those things just sort of become an automated event. It becomes something that happens passively in the background rather than something you have to plan for every 5 years or by research grant. Yeah.
So let's talk a little bit about how we've been talking about automation and the fact that we can now bridge data across. But we have a question in the chat. Can you briefly show how data policies work? We can't demo that here, but let's do it verbally. Let's talk a little bit about, because we have a concept at Hammerspace of objectives, and sometimes that needs a little bit of an explanation. A policy might be, okay, I want to move, this to that. But an objective is a goal. And one of the reasons that we can do this, of course, is because we're leveraging multiple types of metadata. So it's all the POSIX file system metadata that might trigger a tiering event, such as, oh, the file hasn't been accessed in a certain period of time, move it from A to B. But an objective can also be a business rule, a plain language business rule that says, I want this class of data, whether it be based on its size or the department it belongs to or the project it is or the instrument it came from. Walk through a little bit about how an objective can be used in this so that instead of a migration event, that migration now becomes an automated orchestration behind the scenes. Just walk it through a little bit so that our questioner can get a sense of what we really are talking about in a real world sense.
Sure. So I think it's important to also maybe subdivide objectives a little bit and think of them in terms of, as you say, that plain language business goal for that data and its life cycle. But within that, we also want to define the different places that are participants in that conversation. It's really important to call out that when we're talking about this, we show graphics and we talk about this idea of representing multiple storage entities, but we don't have to necessarily represent all of them. We don't have to represent the entirety of any one of them. And so when we think about these objectives, it's important to also look at the resources that are available in that environment and decide what we want to present through that namespace. But then once we do that, also be able to inventory their capabilities from a performance standpoint, a durability and availability. All of these different traits come to play. So we'll define those attributes. And then from there, we can start applying objectives that leverage those different tiers, if you will, within that infrastructure. And as you say, I mean, they can be as simple as, hey, data showed up with a PDF extension and I want it after 30 seconds to move to archive. That's easy. We can make that happen. We can also do various other things like thinking about landing content in one location, but we know that the workflow means that that content's going to be consumed somewhere else. Well, let's proactively go ahead and push an instance of files based on metadata attributes, maybe based on headers that we can go inspect. Maybe it's based on the result of an edge-based post-process routine. Think about an image capture happening out at an edge location somewhere. And maybe I have enough capability at that edge to execute an image recognition routine against that file and start picking things out. Is that a beach ball? Is that a child? Is that a car? Those kinds of things. And different metadata results from that routine can now be used to orchestrate that data based on what's going to, we want to dive in a little bit further on what kind of car that was. Maybe how fast it was going. When was it last seen elsewhere? We can start tagging all these things on the fly and responding to data or responding to application needs through those objectives as well. We can also then, to your point around data migrations, what if we just brought a new storage entity in it? We've got the next big thing. It's super fast. It's super fancy. They got a better looking bezel than the last guy. What if we just put that into the infrastructure and said, now let's also promote some of that data into that tier as it gets used, and then maybe move some of the other things elsewhere from the older tiers. We want to expire that and take it out of the
So you might take the older storage, and instead of it being the primary, it becomes the secondary. It's still got life in it, but you want whether it's the cost profile or the performance, whatever for the new one. But you just do that. You add it into your storage fabric, and then you set an objective. I wanted to catch on when you mentioned earlier, and that is, durability. I mean, isn't within Hammerspace, you've got a checkbox, do you want this 4 nines, 5 nines? And that can just be a checkbox along with other checkboxes that decide this class of data or this share or this project or whatever can live, but also it could be cost, right? I mean, we, within Hammerspace, we can determine, a cost profile and even model the cost profile so that if the data is going to live over here on the most expensive array, then, you can decide, based on an objective, I don't want to spend that much money, or I want to be able to charge back or show back, what those costs are for living here, and just seamlessly in the background migrate it to, more affordable for that slice of time that data needs to be used, right?
Yeah, that's right. I mean, all of those things, cost, durability, availability, performance metrics, those are all things that are checkboxes and or, text entry boxes, things that we can plug in if we know, if we want to do the math ourselves on certain things. And then from there, being able to decide things. I mean, how cool would it be? You think about some of the workflows, some of the compliance workflows where data originates, you want to do some inspection on it and then protect it for some amount of time, 7 years, 30 years, whatever the case might be. Floyd, you've said this many times in prior conversations that the infrastructure is going to the data is going to far outlive the infrastructure that it gets placed on. So now let's take this idea of these objectives and apply them to metadata, that the metadata will live with the data. That will live on beyond that infrastructure, and those rules will live on beyond that infrastructure. Now, what if you have that ability to reach in and say, well, let's update those attributes of that infrastructure to fall in line with the modern problems or the modern challenge statements of that business, and have that data now move around accordingly.
Or like we were talking about earlier, in a research environment where you've got the shadow IT with the NAS sitting under the desk, well, that researcher goes away. They don't necessarily know what is on that. But with automated inherited metadata, inherited custom metadata, that little array can now be seamlessly, attached into the global data environment, the Hammerspace environment. And so now central IT, without having to disrupt the researchers, they know that that stuff is there, right? It's tagged. An objective can be set that says, okay, we need, some of this has got, serious IP. It needs to be protected in a certain way. It can only be shared in a certain way. It needs to be, an archive copy needs to be put somewhere, right? Yep.
And what's really cool is I'm fascinated by simple things at times. And one of the simple things about doing this, it's easy to fall into this trap of hearing us talk about this stuff and think, oh my gosh, that sounds super complex. One of the coolest things about the way this all works is as you're defining, if you've defined all your tiers the right way in terms of their performance profiles, durability, that kind of thing. When you're building out these objectives and you want to think about where that data is physically going to live, if you want to manage it at that level, the UI will actually prompt you and say, yeah, like right now, based on your requirements, these storage systems in the infrastructure are capable of honoring the requirements you have for this data set. As you move sliders one way or the other, that list will change. And it'll just automatically say, you know what, at some point you can whittle it all the way down and say, you know what, this is the only thing in the environment that can meet those requirements. And then from there, you can say, always place at least the first instance of data there. Whatever else you do from there, you can get crazy around how you want to protect it or otherwise. But make sure it always lives in that one, as an example.
That's right.
Really, really cool, really flexible, and most importantly, super easy.
So what we've been talking about today is, we started with the notion of, okay, data migration is a problem, an event typically that, IT directors and users, in fact, have to deal with in, when the data does outlast the storage it's on today, or if it does need to go to a different cost profile, or if it does need to be shared with somebody elsewhere. And so that's one problem. But you just touched on something there that I think is that let's highlight. So data orchestration as opposed to data management. Data orchestration is the free flow of data based on the objective. We call it within Hammerspace to align, that the storage and the data is aligned to its objectives. And so that will change over time. So this is automated orchestration as opposed to copy-based data management with point solutions across silos. But there's and so that ability to spread out all of this data orchestration to meet the needs of the business, meet the needs of resilience and so forth. But you just triggered another one, which I think is going to be the topic of our next in this series, and that is data protection. Because it's one thing to move data around to facilitate a workflow, but doesn't data protection also suffer from the same issues where you've got different types of protection, whether it's sitting on a NAS or an object store or in a cloud or on even different NAS vendors?
Yeah, and to your point, we want to make sure we have enough to talk about on the next one. But to touch on some of those things, that you're right. There's the challenges of where does the data originate from? Where are you taking it to? Why? What do you want your recovery experience to be? And all of those things are, in fact, just copies of that data, and they come with all the same challenges. I've got to seed that workflow. I've got to deal with version control. I've got to be able to now, I'm actually multiplying my problem a little bit if you think about it, because I've got my migrations of my primary storage where the data originates, and now I've got to go from one tape vendor to another, or one tape technology to another, or and at some point you got to maintain that backwards compatibility as well, else you throw everything out. So
sure,
it's an interesting challenge statement for sure.
Yeah. So again, this is LinkedIn Live from Hammerspace, where we're talking about data migration and automation of data across data silos. We're going to wrap up here in a couple of minutes. If you have any more questions, please put them into the chat. But let's summarize a little bit. We've been talking about the need to shift the thinking from an event-based migration to a more automated orchestration. You highlighted the fact that often when people think of automation, they think, oh my God, I got to hire an automation engineer, or it's going to be complicated. And yet what you just said and what we'll continue to outline is how, based on the metadata, because you've elevated the file system out of being locked into these siloed infrastructures, now it actually becomes a lot easier, right? You can you can implement the objectives and run this across. So it goes from copy-based management to really data orchestration, automated orchestration across any storage, right?
Yeah, and I think the most powerful thing I've heard a customer say when seeing this in action is they had that moment, and it's the best part about being involved on the customer side, is on the user side, is being able to see that oh my gosh moment. And that oh my gosh moment that this person had was, I never have to do another data migration again. I never actually have to plan for any of that garbage. I can just say, here's a new set of media. Here's the way I'm going to attach it to my fabric. And I'm going to instantiate that into that metadata layer that is Hammerspace, and I'm done. I don't have to do anything else.
That's great. That's great. So that's a great way to wind it up, Brian. So please check out hammerspace.com. On there, we've got a series of videos and white papers and so forth for more information. You can reach out if you have questions, reach out to us or to via hammerspace.com. And I think what we're going to do is continue with this theme. We've gotten a lot of feedback, interest in this, because what we're doing is really changing. This is a different way of thinking. It enables people to think differently. Brian, you mentioned the aha moment that customers have. I love that when they get it. It's just like, wait a second, I've been thinking with this storage-centric view, and sure, you need storage. The data's got to live somewhere, but it shouldn't be locked there, right? And it's that aha moment when they can shift to a data-centric, view where you're using business rules or objectives, business-driven objectives, and then all your different storage choices in the background, they become a palette that you can paint with to do what you need. Where one department needs one thing, another department needs another, one project needs another, but it can all be in this fabric across whichever storage vendor that suits you the best, right? Yeah, so I think exactly. what we'll do is, the next event will come at the same time as this one on February 15th. And we're going to be focusing on, again, data automation, but now we're going to be looking at data protection. How does this deal with when you may have, whether it's snapshots or whether it's other sorts of protection, and we'll get into a lot of that detail, but how do you automate this in a siloed environment, in a multi-site environment, in a multi-cloud environment, or any combination of all of those things? So join us, please. You'll see on LinkedIn and through our social media, you'll see invites to that one. But please join us at the same time on February 15th for the next in this series on data orchestration and automated data across silos using Hammerspace. Brian, as always, thank you very much. It's been a great conversation. And to all of you joining us on LinkedIn, please, thank you very much for your time, and check out hammerspace.com for some more information. Thank you very much.
Always fun, Floyd. Thank you.
All right.